Because there is a vampire around, who sneaks into the software development projects and sucks the blood of your fellow developers. And today, my goal is to take him out. I'll need your help. We're gonna stab him with a silver dagger into his heart, put a holy cross on his chest, sprinkle with holy water, and bury some 3 feet under the ground. And all I ask from you, please don't dig it out. And don't talk, because he will suck your blood again. You might know it, some of you. He's known as Waterfall. And he's really a serial killer. He has a really efficient and impressive record track. The majority of projects he was sneaked in, either were underachieving, died before the delivery date, or simply left bleeding to death. It's recently, you don't hear much about Waterfall, but recently he's been disguising and big design upfront. This sounds a little bit milder, but still, it's the same guy, same dangerous. It's a special kind of empire. It feeds exclusively on the blood of programmers. It really behaves well with other engineers. He's really helpful there. But, if he meets a developer, a programmer, then expect no mercy. The good news is that by the end of my talk, he will be dead. So, as you already understand, today I am going to talk about the design in software development. It will touch the most important question. How much design, technical design, upfront, ahead, you have to do? What is enough? How much paperwork you need to do before start coding? And this is all what design upfront is. That is, you plan something without coding, and only then you start to code. So the size of the design upfront is easy to check and calculate, because it's simply the time and the effort which you spend designing an application, a new feature, a new big component without starting to code. You already can feel that I am not a big fan of big upfront design. And in this presentation, I'll try to explain why. And I also want to explore alternatives, because there are some. And in particular, it's emergent design. How many of you heard about emergent design? I have quite a few. Good. How many of you heard about big design upfront? I'm sure there are more. So, software engineering and software development as a discipline is still very young. And in its early days, it was really heavily influenced by the real engineering, like civil engineering, mechanical engineering, electrical engineering. Civil engineering is all about constructing bridges, airports, railroads, infrastructure, every kind of building. Mechanical engineering is about producing engines, cars, space shuttles. So, and big design upfront came from there. If you are to build a new skyscraper in Vilnius or a new bridge over Nemunas, you don't just start building it. It's natural that first you need to get some engineering drawings, blueprints, where each detail is thought in advance You figure out everything in advance. You put it into a detailed document. And the decisions which architects do, engineers and architects do, I mean, they are based on the knowledge which has been accumulated throughout years. There has been many experiments with construction materials and design solutions. They already know what works. If they choose some solution, they already know that it is going to work. There was lots of rigorous testing, validation, formal, in laboratories, and they know what works and what doesn't. So whenever a civil engineer or an architect finishes his blueprints, he's pretty sure that this is going to work. Then all he needs to do is simply to pass this engineering blueprints to a manufacturing team, a building team, which in the real engineering is more or less always a different company. There are companies who design buildings, there are companies who build them. And these blueprints are detailed enough so that the construction company, manufacturing team simply follows all the instructions to build the building. They don't need to interpret it. So big design upfront, I mean, is more or less the only way to build buildings, to launch space shuttles, to build computer parts, all electrical devices. Because you can't just get them somehow working. I mean, you need a plan. But it's different. I mean, just think about this. Despite this really huge thought ahead, I mean, still major mistakes are made, even in this real engineering. I mean, big mistakes. I mean, billion-dollar mistakes. So no matter how much thought you put up front, no matter how much money you throw at big design up front, I mean, it's still not guaranteed. It doesn't work 100%. I'll give you just some examples, but if you look around, you will see many of them. I mean, dams collapse because the important geological factors were overlooked and the wrong design decisions are chosen. Spaceships, I mean, they burn down together with their multi-billion budgets. I mean, in particular, let's say in this case, there was an error in the software design. So the NASA subcontractor, Lockheed Martin, created a thruster software to manage the engine. I mean, and this software was operating in imperial units, you know, pounds. But NASA was using metric units. So the situation is something like that. That imagine that you, Europeans, go to US, rent a car, drive to a motorway, and then speed till 100. I mean, you expect that you are going 100 kilometers per hour. But it's America, I mean. And most probably you are speeding 100 miles per hour. So similar mistake happened there. I mean, the navigation commands were sent in different units. Engines understood them straightforward, and the probe actually hit the atmosphere at the wrong angle, and that's it. It burned down. I mean, I don't need to mention you how much hardware failures. Chips are launched with major problems. I mean, this you know better. Exactly. I mean, I'm not arguing about this. I'm just telling you that this big design upfront still doesn't succeed always. It still fails. Yeah, I mean, you always have this dilemma. But I mean, is NASA budget is big enough? Is not big enough? I mean, do they have time frames, I don't know, of several years? And they still make mistakes. So, I mean, you never be sure. But still, I mean, that's more or less the only way that works in real engineering. I mean, there are no alternatives, more or less. But, so, I'm just wanting to explain the history. I mean, how this big design upfront came into software development. I mean, in its early days, software development had no established methods of how to deal with software development process. So, you know, it sounds so natural that first you think everything, you write the requirements, you create a design, then you implement, then you test it. I mean, it's natural. Each director of any company says, yes, of course. But, so in that way, the big design upfront sneaked into software development. I mean, you should remember waterfall. I mean, waterfall is the big design upfront in its purest form. I mean, 10 years ago in Lithuania, coding using waterfall for building software was like a sign of good education. I mean, because more or less the only known alternatives was chaos. I mean, when projects simply were not really managed, they simply happened. There was some requirements gathering stage, then, I mean, some estimations trying to be on the same side. Then simply developers somehow hack the features together somehow to make it work. And the product which was produced, usually if delivered ever, I mean, usually was buggy, convoluted, and unmaintainable. So, I mean, in the darkness of that chaos, the big design upfront looked like really a shining star. I mean, the light at the end of the tunnel. And if such a project failed, I mean, which was frequent. I mean, I started my career at such projects. Because at that time, I mean, really, there are no alternative, either big design upfront or this cowboy coding style. So, big design. So at that time, I mean, if the project underachieved or failed, it was usual to blame, let's say, business analyst, you know, say that architects did the bad job. I mean, architects say that business analysts did not gather full requirements. I mean, they need to work harder to get all the requirements. Programmers were always unhappy because the architects provided something which does not work in reality. But nobody at that time were questioning the big design upfront process itself. And I mean, let's look. What are the problems with big design upfront in software development? I mean, first of all, I mean, it's awfully hard to think things out in advance. I mean, you need to make it right from the first time. Personally, I mean, I think that such people are very rare, and I don't know them. I never met them. I mean, you know, you can scribble down some high-level architecture of the new component or fancy new big feature, but then you start dig deeper. I mean, and you find out more and more possible workflows, more and more critical cases. And then you need to think how to deal with them. I mean, you can literally spend days on sitting on the design and each day finding out something new. And this, I mean, in my experience, some 6 years ago, was really frustrating. I mean, you sit on the papers, you know, there is nothing still working, and you still find new things, and you can't really start working. And you don't know that this approach, the decision you take, will they work or not. Another problem with big design upfront is that I need to make my design right from the first time. So what does it mean? So I need to make him somehow, bulletproof. So the most easy way to cope with it is add flexibility. So I make my design flexible. I need, let's say, database, yeah? And I'm still not sure which database to use, so I add abstraction layer. Additional abstraction layer. I mean, maybe it's MySQL, maybe later I will switch to Oracle. I don't know yet, but I add this flexibility in advance. So if the flexibility I add ahead is not used, then I over-engineer. I simply make my code base larger, more complicated than it should be. Remember the first keynote where Mr. Weinsberger told about the accidental complexity. So this flexibility is part of it. And it's a killer. So, you plan for flexibility so that your design, you can cope with changes, with future changes easier. But in the end, we come to a different conclusion. This added complexity by flexibility actually makes the future changes harder. So let's say I somehow managed to make my design right with not too much over-engineering. And still, we have another master changing requirements. And from this guy, you can't hide. Majority of software projects, absolute majority, unless you work for NASA or some, atom plants, deal with changing requirements. And whatever I design, I spend 2 weeks on my pretty nice, good design, and then the change comes. So this means that I simply wasted my time. So there are real problems with it. So the main idea behind the big design upfront is that the changes later are very hard or will cost you a lot. Of course, if you have the situation like this, yeah? Most probably it will cost millions, or maybe you will have to destroy it and simply build a new bridge. Such bridge misalignment cannot be fixed. But this is civil engineering. We are developing software. Software. It's called soft, not without a reason. So there is no background, no reason for it to be hard to change. And software development is completely different, from civil engineering. When you build a skyscraper, the design itself, the blueprints, cost just a fraction of the whole budget. It's just, 10% maybe. All the other prices for materials and building. But software, come on, materials. What materials? Bits and bytes are for free. Building, it's compiler work. It's cheap. The CPUs are now fast. And changes are easy. If you, let's say, foundation of houses are made of concrete, yeah? If concrete stiffens, there's not much you can do about it. Changes are not possible. And that you can call a hard change. But software is soft. So materials are cheap. Building is cheap. Changes are easy. So what is the most expensive part of software development? Anyone? It's design. Because programming is not about building software. It's about designing software. Back in 1992, Jack Reeves wrote an article in C++ Journal called What is a Software Design? I really regret that I found this article only recently and not some 5 years ago. Because I found there very good insights, which are revelating, which are enlightening. Putting the software design into a new light, different angle. So he says that in software, everything is part of the design. It's testing is a part of a design. Debugging is part of a design. Everything. So, I mean, why? So let's look. I mean, you know, in software development we have a specification, actually a document which says what needs to be built, right? Then usually it is followed by a technical design document, which says how these features should be built, the technical design. But if you compare these designs with the ones in the civil engineering, I mean, they are still not that detailed. If you get a technical design for software project, you cannot simply do or literally follow the steps and, I mean, deliver the software. You still need some kind of interpretation. You need to interpret. You need additional thought, creativity to implement that design, which means that software designs, documents as they are called, they are not detailed enough. Their designs are not complete. And then we go further. I mean, then what in software development is the design document, which, I mean, can be the same level of detail like in civil engineering blueprints are. The only document detailed enough, unambiguous enough, that you can simply literally follow the instruction and build the software is the source code. We, developers, programmers, create designs in a programming language and give it to a compiler to build it. Which means that a design, I mean, it does not end up with some upfront design. The UML diagrams, the technical documents, they are simply incomplete. I mean, you know, you still need to interpret them. You still need to solve the implementation details because UML diagrams doesn't deal with implementation details. And moreover, I mean, this technical documentation, it cannot be validated. Whatever you build with words or bubbles and squares, you are never sure if it is going to work. There is no way to validate it unless you build it and test it. Think about that. I mean, we create design in a programming language. We give them to build to compilers, which means that creating a design, a software design, is very expensive, but building is really cheap. And if you want to validate, to make sure that your design works, the easiest way is simply to design it in a programming language and then build it and test it. There are no easier way, no shorter way to do that. The only way to validate software is by building it and testing it. So here we are. I mean, in software development, materials are cheap, building is cheap. I mean, changes, unless you make somehow deliberately hard, they are easy. If we agree that design is done in a programming language and not in UMLs, and design is only completed after you build it and validate it, because there are no other way to prove that these bubbles work, then why should we waste time on the paperwork? Here I want to mention, I mean, it's not that I am against UML or these documents. I mean, they are okay. If they help you to get a better understanding about the system, they are really highly abstracted, not the low level, not about the database field, not about the class diagrams with all the method inside. I mean, if it's just high-level architecture to visually imagine the system architecture, then it's fine, use it. But you just need to remember that this is incomplete. You build, you test it, and then you know if it works or not. Until then, it's just a paper. So big design upfront or design upfront comes in different forms. I mean, its intensity ranges, from waterfall, which, as I mentioned, is a pure form of big design upfront, to cowboy coding. I mean, I mentioned this. So waterfall says that everything, the design should be done before you start to code. Big design upfront is a bit milder. I mean, but you still need to do a whole lot of design ahead. Then you have somewhere in the middle, less design upfront, or some design upfront. So do we have, I mean, we don't want to talk about cowboy coding, right? So what are the alternatives? And there are alternatives. There are agile alternatives. One of them is emergent design. The position or design upfront intensity in this scale is hard to tell, because emergent design works with some design upfront, a little design upfront, or no design upfront. I mean, it's more or less depends on your skills and experience. So how does this emergent design works? So in the beginning, there is no result, no design. You start with implementing a small piece of functionality, A. You finish it, then you move on to functionality B. After you implement functionality B, or while implementing functionality B, then you look at the source code and you check for code duplication, for commonalities. You refactor them out. Remove all the code smells. You end up with a clean code base, small, which is just enough, just complicated enough to serve these two features. In this way, you allow the architecture shape and emerge. You don't anticipate for the future. You don't develop for the future. You don't add flexibility for the future. You just allow the architecture, the design evolve. And then you continue adding functionality C and then refactor mercilessly. I mean, your task is to keep it optimal. So for the current feature set, it has the optimal architecture, not more than necessary. Then it's easy to maintain, easy to read, less space for bugs. Emergent design says that decisions which are made early in the project are very risky, because tomorrow you will know more. I mean, you should feel that from your experience. My experience shows that whatever we try to build upfront, we always overlook important information. And only after hit the coding phase, when we start coding, then we know what works and what doesn't. And what is even more important, we notice what we have overlooked, which we did not expect. Thus, it's important to learn and to be able to defer the decisions, especially the architectural ones, until the last responsible moment, until you know more information. That is why, let's say in Agile world, spikes are so popular. So whenever you plan some new feature, which needs to support, millions of records in the database, multiple and heavy read and write load, and you don't know if, let's say, MySQL or a MS SQL server, will it hold the I mean, will it withstand the load? And if you don't do a spike, you don't test it, but you do the big design upfront based on the notion that this is going to work, but it won't, then your design will be ruined. So it's really important. That's one of the emergent design rules, that coding reveals new information. So it is important to start code. We talked about the easiness of doing changes. I mean, more or less keeping the cost of change low. And the first rule, which is always underestimated. I mean, there are lots of architects among us, yeah? I mean, we know lots of design patterns. We know lots of libraries. And we try to use them. But we need to think, is it the simplest solution? In my experience, I mean, talking about the simple solution, again, I need to return to this accidental complexity, which you add. Don't underestimate it. I mean, it will kill you eventually. If you choose a complicated solution multiple times over the simple solution, you end up in bigger code base, hard to read, hard to maintain than it should be. Keeping the code base clean, I mean, it's the only way to stay alive and to make these changes to happen easy. But you can't do, just can't do emergent design without a few prerequisites. I mean, you don't get it for free. So, and these prerequisites are test-driven development, continuous integration, and refactoring. Talking about the first one, if we don't do test-driven development, if we don't have tests which provide a safety net for any change, I mean, we can forget. I mean, this evolving design, emergent design won't work. But design upfront won't work as well. So, talking about the tests, I can tell you from my experience what it means. I mean, it's not that easy to write a good test. I mean, you need to know that the moment you start tests, you need to maintain them. The same like your code base, in the same good shape, always clean. I mean, it's like a project on its own. You have your features, you have your code base, and you have tests. They come together. You cannot neglect your tests, because otherwise they will lose value and no use for you. I mean, if your tests randomly fail, yeah, which is again another killer for your project. Because if your tests randomly fail, I mean, you do a build, and then you run the test, and then something fails. And if it fails frequently, then developers simply, they get immune. I mean, okay, failed again, so what should I do? So it's very important to keep them running and successfully running. So the first thing, if you break the test, you need to bring it up immediately. Continuous integration is, you can't do it again without it. I mean, by talking about the continuous integration, I mean that each feature you do, you need to integrate in the whole architecture, in the whole system as soon as possible. And that's why I don't like branches. I know some branch proponents which say, oh, how good is this, I can develop in the branch, I mean in the source code repository, I mean like SVN or Git or some others. So I develop in the branch, and then when I finish the feature, then I integrate. First of all, you don't get the benefits of continuous integration, that you don't know if your feature, after adding, still works. Second, you get out of sync with the development team. If you're working alone, I mean, then you don't need a branch. If you're working 3 persons, then again, more or less you don't need, because not much changes happen. But if you work in a company where we have, let's say, 100 developers, which commit very frequently, I mean, this means that if you change something in the branch, and after 3 days you will try to merge this into the trunk, you will get many conflicts. Especially if you change something in the design. I mean, imagine you split a class, you saw that big class, yeah? which is doing too much. You split them in two in your branch, and then you try to commit. You are dead, more or less. After you merge this merging horror, then you already see that next time you won't want to refactor, which again will deteriorate your code base, and over time it will degrade. And while degrading, I mean, if you're working on some short projects, it's okay. I am working on products which last years, which always alive, lots of changing requirements. And if I allow technical debt to accumulate, I'll be dead. If not today, then tomorrow. Each change will be harder to make. So don't be, I mean, I don't like branches because they somehow ruin the continuous integration concept. Refactoring, another, the third. I mean, refactoring is all about improving your code base. It's like being pregnant. Either you are or you're not. I mean, you can't, it's not enough just a little refactoring. That won't work. Because a little refactoring means that technical debt, the complexity, accumulates over time. And eventually it will kill you. So refactoring means aggressive refactoring. You add a feature, you need immediately to remove all the code duplication, to bend the architecture, the design into the right position, to keep it minimal, optimal. So these are the main important three prerequisites which we need to consider before starting the emergent design to work. But if you do that, I mean, you will be rewarded. Talking about the tests. So, you know tests. Usually people say, oh, test, I have tests. Yeah? And usually they write tests after. But then, I mean, it's important to understand that test-driven development is not only about testing or validating what you did, but it's also important for your design. Because if you have some feature, you don't need to think about the whole lot in advance. I mean, you need to split that feature into small steps and then do these small steps. Write a test for each small. Then you end up with small methods which are tested separately. And then you simply combine, you know, the design pattern for composed method, where you use short methods to do the job. So if you do a real TDD, then you will see that your design will be much better as if you do the test after. Because you end up with doing tests after, you usually end up with longer methods, bigger classes, and a more convoluted code. So in the end, I mean, how much upfront design is enough? Well, I mean, some guys say that B is bad and L is good. So big design upfront is bad, but less upfront design is good. Some of them, like such XP guys as Ken Beck or Ron Jeffries, say that it's almost eliminated. I mean, you just need to start coding as soon as you can. Don't spend time, because usually you think the things out. We personally, I mean, it's in my team, we don't work with lots of paper design. We usually scribble some, you know, when we have some new big component to make, we make some high-level architectural thing to imagine how it will look like. But we never go too much into the details. Because then, I mean, you burn days. I mean, I can feel like the team working 2 days on simply thinking the things out, you know, noticing new information and then thinking how to deal with it. Or maybe this will work or not. I mean, it's really frustrating and it's demotivating. So people, I mean, we just do just a little design upfront, and then we start coding. And after we start coding, then we adjust the design. We check what is correct, what is wrong, what are the next steps, and then we follow. And in this way, you get this architecture thing, you know, you don't think things in advance. And this works. I hope it could work for you as well. Because big design upfront is really not the solution. I mean, unless you are working in a really restricted environment, or let's say doing some medical software where lots of formal and regulations which you need to meet, because otherwise you won't be accepted into business. But this part of software is not really a majority. For majority of software, you don't need big design upfront. So that's why I really like this concept of emergent design, and that the real design document is source code. So you don't need to play too much with paper designs. Because only after you build it and test it, which is the easiest way you can do, the most cheapest way you can do, only then you will know if it works or not.